Flu is a bigger deal than people think. There's a new flu vaccine every year, and the people who are resistant to that have usually never had influenza before. Once you do, you're not going to argue about getting the vaccine again. So we are going to research some influenza or flu weird on today's episode of 5 Weird Things. Welcome to the channel. I've had influenza twice in my life. The first time I got the flu was without vaccine, and it went on for weeks, about 3, went to the ER twice, felt like I was going to die the whole time. Now the second time, I had just gotten the flu vaccine about 3 months before, then I got the flu. I was actually sick for about 3 days and briefly touched on that feel like I'm going to die feeling, but no trips to the ER. For the most part, I was just feeling under the weather, but I didn't feel like I was going to die most of the time. Now, since then, I do not miss an annual vaccination. What are your thoughts on the flu and vaccination? Let me know down in the comments. All right, let's get into it. First, the stuff we should all know. Influenza, also known as the flu, is a contagious respiratory illness caused by influenza viruses that infect the nose, throat, and lungs. Symptoms can range from mild to severe and can sometimes be fatal. The flu is most common in late fall, winter, and early spring in the U.S., but can occur in all parts of the world and at different times of the year, depending on the location. The definition of a pandemic is occurring over a wide geographic area, such as multiple countries or continents, and typically affecting a significant proportion of the population. Flu does that pretty much every year. Weird thing number 5. It is deadlier than you think. Influenza causes significant global mortality every year. The World Health Organization, also known as WHO, estimates that annual influenza epidemics result in approximately 290 to 650,000 respiratory deaths worldwide. The highest fatality rates from influenza occur among specific high-risk groups, including young children, the elderly, pregnant women, and individuals with underlying health conditions such as heart disease, diabetes, or chronic respiratory illness. The number of fatalities can vary significantly from year to year, influenced by the virulence of circulating strains, vaccine effectiveness, and the level of immunity in the population. A significant proportion of influenza-related deaths are due to complications such as pneumonia, which can be particularly severe in vulnerable populations. Secondary bacterial infections following the flu are a common cause of these complications. Now, the burden of influenza fatalities can differ markedly between regions. Low and middle-income countries often experience higher mortality rates due to factors like limited access to healthcare, lower vaccination coverage, and higher prevalence of chronic conditions that can exacerbate the severity of the flu. Weird thing number 4. Types of flu. The influenza A virus are the most common and known for causing pandemics. They're divided into subtypes based on 2 proteins on their surface, hemagglutinin, which is the H, and neuraminidase, and that's the N. I'm probably mispronouncing them, but let it go. Now, examples include the A1N1, which was responsible for the 2009 swine flu epidemic. Influenza A can infect humans, birds, pigs, and other animals. Influenza B primarily affect humans and are not divided into subtypes. However, they are classified by 2 main lineages, B/Yamagata and B/Victoria. While influenza B can cause seasonal epidemics, it does not cause pandemics. Influenza B tends to mutate more slowly than influenza A. Influenza C cause mild respiratory illness, are not known to cause epidemics. They primarily infect humans, but have also been found in pigs. Influenza C infections are less common and generally result in much milder symptoms compared to influenza A and B. Influenza D primarily affect cattle, are not known to infect or cause illness in humans. Discovered more recently, in 2011, influenza D does not pose the same public health risk as other types, but is of interest in veterinary medicine. Influenza A and B viruses undergo 2 types of genetic changes. Antigenic drift involves small, gradual changes in the virus's surface proteins, leading to seasonal flu outbreaks. Antigenic shift, which occurs only in influenza A, involves abrupt, major changes, potentially leading to new subtypes and pandemics. This shift can occur when an animal flu virus mixes with human flu virus, resulting in a new virus against which people have little to no immunity. Incidentally, that's why we get the new flu vaccine every year, because it's changing, it's morphing, it's becoming something different. So they look at the most prevalent strain and they kind of tweak the vaccine to fit. Weird thing number 3, flu vaccine. Traditional flu vaccines are grown in chicken eggs, which can be a problem for people with severe egg allergies. However, there are now egg-free alternatives available, such as cell-based vaccines, which are grown in animal cells, and recombinant vaccines, which are produced using DNA technology. Many flu vaccines are now quadrivalent, meaning they protect against 4 different strains of the flu virus. 2 influenza A strains and 2 influenza B strains. This offers broader protection compared to older trivalent vaccines, which only covered 3. Recent technological advancements has significantly reduced the time it takes to produce flu vaccines. For example, recombinant technology can produce vaccines much faster than traditional methods, which is crucial during a pandemic situation. Not just flu vaccine, think back to COVID. We got the vaccine out in a record amount of time, and for the people that were skeptical of it, yeah, they all have a story about it. If you get into the science, it was fascinating how fast they got that to be a completely tested, ready-to-go vaccine. Scientists are working on developing a universal flu vaccine that would provide long-lasting protection against multiple strains of the flu virus. This would eliminate the need for annual flu shots and offer more consistent protection. The effectiveness of flu vaccine can vary from year to year with the current vaccines. Typically, it ranges from 40 to 60%. This variability is due to factors such as the match between the vaccine strains and the circulating strains, as well as the age and health status of the person being vaccinated. Despite this, the flu vaccine consistently reduces the severity of illness and the risk of serious complications. Weird thing number 2, flu symptoms. While the flu is primarily a respiratory illness, some people, especially children, may experience gastrointestinal symptoms such as nausea, vomiting, and diarrhea. These symptoms are more commonly associated with the flu in children than in adults. Now, unlike the common cold, which typically develops gradually, flu symptoms often appear suddenly. People can go from feeling fine to very sick within a matter of hours, experiencing a rapid onset of fever, chills, muscle aches, and fatigue. Flu-related muscle aches and joint pains, known as myalgia and arthralgia, can be severe. These aches are due to the body's inflammatory response to the illness and can even make simple movements painful. Even after the acute symptoms of the flu have resolved, many people experience lingering fatigue and weakness that can last for several weeks. This post-viral fatigue can be debilitating and impact daily activities long after the fever and aches have subsided. The flu can weaken the immune system, making individuals much more susceptible to secondary bacterial infections such as pneumonia, sinusitis, or bronchitis. These secondary infections can lead to a worsening of symptoms and may require additional treatment. And finally, weird thing number 1, the deadliest strains of flu. The H1N1 strain caused by the Spanish flu pandemic in 1918 was one of the deadliest pandemics in world history. It infected about 1/3 of the world's population and resulted in an estimated 50 million deaths. A variant of H1N1 reemerged in 2009 as the swine flu. We did much better this time around. Now, the H2N2 strain led to the Asian flu pandemic, which started in East Asia in 1957. It spread worldwide, causing an estimated 1 to 2 million deaths. This strain originated from a reassortment of avian and human flu viruses. The H3N2 strain was responsible for the Hong Kong flu pandemic in 1968. This strain also emerged from a reassortment of avian and human flu viruses. It resulted in approximately 1 to 4 million deaths globally. The H5N1, commonly known as the bird flu, is a highly pathogenic avian influenza virus. While it primarily affects birds, it has infected humans, leading to a severe respiratory illness and high mortality rates. Human cases are rare, but often fatal when they occur. H7N9 is another avian influenza virus that emerged in China in 2013. It has caused sporadic human infections, often leading to severe respiratory illness. The mortality rate among those infected with H7N9 is high and remains a concern for potential future pandemics. Well, that's it for today's episode. Flu always scares the crap out of me, so I figured I'd share the fear. Please like and subscribe, share the video if you can, or at least click one of the videos above. Leave any thoughts or opinions down in the comments. If you are still watching, today's code word is outbreak. Put that down in the comments to do absolutely nothing to help stop the spread of flu. Take care, have a great day, and stay healthy.